All right, welcome to more day 20 Advent of Code. We're picking up where we left off yesterday, I guess. Didn't get around to coming back and doing more work on this problem, this image tiling situation here. So we'll continue here, right? I've been, as one does, thinking about it in the back of my mind a little bit, and I have some ideas. We'll see how they play out. And yeah, with that, I'm gonna start today off with some writing. We've got some plans to write out because this problem, I don't think it's hard. Well, we'll see if it turns out to be really hard. But I think, at least for now, it's straightforward in the sense that it's just a big engineering problem. We just need to piece it all together. So let's go over to our text file here, and what I have in mind, right, in terms of plans is there's a couple things. So we've already built up the beginnings of this class, where we have this tile class. I have this kind of flipped and rotated situation, which is a little bit like, and I'm still kind of thinking through how to properly do the flip and rotation to like get the borders to reveal correctly and things like that. But for the time being, I have some thoughts I want to jot down. So the first thing that I want to mention is we definitely should track, borders. I'm talking about borders need to be cached. I think we're going to be retrieving the borders a lot. So when we get borders, kind of if they're not set, then we will update them. But generally, I suspect that we should be saving these as instance variables and updating them when we do flips and rotates and at no other time. There's also the broader problem of kind of our image has jagged edges that need matching. Like, how do we match a image tile kind of into a corner, right? It's going to touch on 1, 2, possibly 3, or even maybe 4 sides of 1 to 4 sides. And I'm thinking about this in terms, like, at a high level, that when we think about the structural breakdown of how the logic will branch, it's going to be like, pick a tile to start with, and then we have these 4 edges, and it's like, are there any edges out there that match? We know there has to be at least one, at least at the start, right? Because otherwise this tile won't match anything. And in fact, every tile could have one or more matches throughout the entire data set. And so we kind of like imagine like this floating tabletop of all these tiles, and it's like, whoosh, these two get matched together. And then now we have this shape that has 1, 2, 3, 4, 5, 6 edges, right? We have 2 tiles together, there are 6 exposed edges. And any of those edges could be candidates, right, for connecting a tile to it. So we need some logic to track exposed edges of the image, remove formerly exposed edges upon adding a new tile, and add newly introduced, right, edges. So when we add a new tile, that tile's exposed edges should show up. One more thing about edge matching. I want to convert the hashes and dots into 1s and 0s. So the hashes will be 1s and the dots will be 0s, just like we saw before. And the reason for that is then convert the 4 edges into binary, 4 string edges into binary numbers, reverse, and also store those. So now we have kind of the edge, it's flipped rendition, and then we have kind of an easier to test intersection and belonging than doing it with strings. Now this whole thing is kind of a maybe, because it's possible that the string kind of intersection and string, is this in that, checks will still be fast enough. I just know that comparing integers will be a lot faster than comparing strings at the end of the day. So that's another thing I wanted to make a note of. Yeah, but for now, I think we just have some just kind of like, we just got to pound out some code in terms of getting the these things flipped and rotated, like get the code in place here. And I'm trying to remember how we did rotation before, right? So like when we rotated in the past, firstly, it's worth pointing out that 2 rotations is the same as double flip. So rotate is this. So when we're in this state, all we've done is that the same as this and this. I think so. So if times equals 1, 2, 3, yeah, 3, 2, right? 2 is the double flip. We're going to call self dot flip and flip it on the x, self dot flip and flip it on the y. And so then it'll be flipped on both. And the problem, of course, is that it will set these to be flipped funny. So I kind of have to fix that, maybe, since I'm doing rotation, not flipping. And that also is, well, I guess the real situation here is that if that's the case, do we care about certain flips and rotations? Like, is there a smaller set of possible states that it could be in than I perhaps at first realized? Maybe. Like, if it's already in this orientation, right? Like, this is one rotation, and we do flip, flip, this is the same as, 90 from there. So in general, like, that's what we figured out earlier. We should never flip something twice. We can flip it around one axis, or we can flip it along another axis, but never both. And that we should still have 8 positions. Like, we have 1, 2, 3, 4, and then we have this way 1, 2, 3, and 4. All we don't need like a full general class to do everything. We just need to be able to generate all of the relevant combinations. And we don't care how we get there. That's the other important thing. So as long as we can accurately generate all the combinations, we're happy. In which case, what if we only did one flip? We don't care about the axes at all. And it's just flipped equals true or false. And so then when we flip, we just only do that. And axes just always equals x. Else print why you pass axes. All right, and let's see. Then when we do rotation, it's not quite as straightforward. So when we do a rotation, in the past we said one rotation moves it. We did this on the, what grid was it? Oh, it was the one where it was on the boat with the waypoints. And so the value in, x comma y rotated 90 degrees was like x, y, rotated 90 degrees is here. It was y negative x. Yeah? Yeah. So x, y, y negative x. So that's one rotation. And then 2 rotations was negative x, negative y, negative x, negative y. So that's one rotation, two rotation, and then three rotations is negative y, negative x? No. Negative y, negative x. Oh, it's up there. It's negative y, positive x. Positive x. And what we saw previously was that each time we did a rotation, we were multiplying, we were swapping and multiplying the y value by negative 1. Swapping, multiplying that. Swapping, and multiply the negative 1. Yeah. Cool. So when we want to generate our, see, the only other thing I'm thinking about is like, I have to zoom out and not get caught up in the tile itself. We want to come up with a solution for matching these tiles. And so in terms of the bigger picture matching algorithm, what I'm imagining doing is creating 144 sets of tiles, tile instances, each with 8 possible arrangements of, each with 8 possible arrangements. Then we'll grab a tile as a starting point, right? So we'll have 144 sets. Maybe that'll be a list. I don't know. List. Like we could also have that be a set of sets. Grab a tile, pick an edge, grab a tile, grab an orientation, pick an edge, and by orientation I mean one of the 8 possible orientations. Ooh, maybe the arrangements orientations, should those be fixed, like indexed? So instead of set, use list. What I'm thinking about there is, should it always be like 1, 2, 3, 4 and flipped 5, 6, 7, 8? You know, like arrangement 1 is always the original one, arrangement 2 is always something, so that we can systematically go through every combination should the need arise. I hope it doesn't come to that. I don't think computationally that'll be tractable. That would be my guess. All right, let's game this out a little further. Grab a tile, grab an orientation, pick an edge, and find a tile set, right? A tile set with edges, with an edge. Let's be real, that matches. The problem is that for any match, there will always be will there always be a corresponding match that is like flipped or twisted or something? I guess not. And you know what? Ah, crikey, I just realized something. The specifics of the orientation do not matter. Like, we don't need to rotate it until we actually plug it into the bigger image itself. Like, it doesn't matter which way it's facing, because like we're going to check all the edges, and just because an edge is up here doesn't mean it can't connect to an edge over here. Like, we'll just turn it, but we don't need to turn it like in advance. Though it could help, but it would because like we want to reduce the amount of stuff that we have to check. And as it stands, we're already going to have to check, I mean, we have to check 8 different edges no matter what. But at least here, we should only check the kind of corresponding matching edge. Like if we have this as the exposed edge, we should only check this edge of all of our 8 mutations, because those are all rotated. So don't check all the sides again. All right, that's worth pointing out. List, grab a tile in a certain orientation, pick an edge like you right, and find a tile set with a edge, e.g. left, right? Like look at all the different, find a tile with an edge that matches. Only search left edges for this. Okay. So then we add matched tile to image, recompute exposed edges. This is what I was saying earlier at the top there. Select next edge to search for match. It's possible, sometimes there's no good match, image edge found. When this happens, go to the opposite side. So it's like if we couldn't find a good match for the top of an edge, go to the bottom, right? Like if we're hitting an edge on one direction, let's just reverse course and go the other way. But of course, there could be a situation where we're ping-ponging. It's from the very top of the image to the very bottom of the image. That's worth noting as well. Oh boy. Okay. And then there's also this thing where we may want the, we need an image library, kind of a tile library, which is probably going to be a dictionary of, you know, codes with a set of tile, like that. Yeah. All right. This is going to be a internal function, get borders. Let's do the rotation. Man, this is almost more like a tile generator, you know, like it's not that we want it to hold, well, it's fine. We can have it hold all the things. So then instead of a set of tiles, we can just have it be a tile. This holds all 8 states and its edges. Yeah, it works. Like the cheap way to do it, right, would be to take the 4 edges, reverse them with 4 more new edges, and those are your 8 edges, done. But the problem is then spatially keeping track of like, oh, we found a matched edge. What are the edges? What are the other edges? How are they oriented? Like you start it. I don't want to go down that route. Though this is definitely one of those. It's the meme from what movie was it? Where the guy's like looks on one side, looks at the other side. You know, it's just like I got two pretty rough options here. But I think for now we're gonna do the rotation for real. So the original is that. One rotation, we swap the x's and y's. So for string in self dot, geez, I don't remember what it's called, image, we're gonna go through and, oh, this is problematic. New image equals list, for each of these strings for character in S, we're going to have a row, new row is a quote quote. This is where I'm starting to think I should have used a list instead of strings, but that's all right. So we're rotating at 90 degrees. Given a dot at xy, its new position will be y, comma, x. Y, comma, x. Strings are immutable. I might have to change up how we do this. The real question for me is whether, like, we don't really care about the contents of the image. I mean, we do because I want to see what the image is, but beyond that, we don't. And so it's like, this will still work. It's still a list of lists. But like, we're passing in image rows, and we're basically taking it at face value. And part of that is because of the way we're reading this in, kind of just as strings. But we can leave that be like that and have the init take care of it. Yeah, let's do that. Okay, so instead of self.image equals image rows, we're going to say it's a new list for string in image rows. How does this break up? String split on nothing. Yes, empty separator. That is the point. All right, so that's no good. Oh, but I remember now. You could just do that. So we turn it into a list by turning it into a list. So for each string, we're going to turn the string into a list and then append it to self.image. Right? Self.image append list of string. And so that gives us a stringified list that we put in the thing, and then image is that. Okay, good. So now, should we provide some good way to make a deep copy? That would be handy here. Copy, but not like copy. Yeah. So self.copy will take self, and it's not really like copy, it's like copy image, right? So let's mark that. Self.image for row in self.image, new image equals bracket, new image dot append row plus bracket. So that'll generate a new row of values for us, and like that. Oops. And so we'll have this new image is a new bracket with a thing, and so then at the end we return new image. Great. So down here, back over here in these times, new image is just going to be self.copyImage. And now we don't need this. And we can say for each s, so now we want indexes. Yes, yes. So our friend enumerate will help us out once again. Enumerate I, j, and then this won't be, it'll be row. Enumerate the row. And so new image at the original value that used to be there is now here. So at whatever value we're at now, it needs to now be moved to this position. Not actually negative I though. Okay, so transposition in non xy coordinates, it's different. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and we want to rotate it one time, it becomes 7, 3, 1, 8, 4, 2, 9, 5, 3. So that's one rotation. And we rotate it again, and we do the same thing. 9, 7, 8, 5, 4, 3. Oh, I typed that wrong. I think I have 2 3s here. 5, 4, 3. Oh, 6, 5, 4. 1, 2, 3, 3, 4, 5. It's because I have 2 3s. All right. Apparently, I have 2 3s. So 5, 4, 3. There's no 6. So fans of the number 6 will be disappointed. Let's be real. 3, 5, 9, 2, 4, 8, and 1, 3, 7. So what I'm noticing is that each time I need to make this row, I am reading from this column. And put another way, when I get to here, you know, and I'm going across, I'm like, up, up, up. I'm going to be writing down this column. I'm going to go up, up, up. And then as I go to this one, it's going to go here, and then this one goes here. So I'm going this order to this order. So this is, I'm at position 0, but actually I want to put it at position, the length minus 1, aka minus 1, and then if this were bigger, right, I'd go to, next one would be 1, and it would be minus 2. So it's like minus 1 minus I is the x position. And then the y position, as this moves across, I want this to move down. There's a reversal here because the coordinates of these are 0, 0, 0, 1, 0, 2. And then the coordinates of the ones we're interested here are 0, 2, 1, 2, 2, 2. So the x is what's changing at the same rate as the y's are changing. The x is changing at the same, so this should be j. Yeah. And in fact, they're changing, they're the same value, so this is actually just straight up j. And then the column position is the one that stays fixed and is negative 1 minus I. So then when you get to here, it's, you know, 1, row 1, column 0, row 1, column 1, row 1, column 2. And then we get to here, the change, right? These become 1. And then the row numbers still are going as j. The columns are changing slower at the rate of -1 minus I. So it started out as -1, now it's -2. Finally, it'll be -3. Nice. So this is equal to the value of C. So it's whatever the actual value is in our thing. Maybe we'll put a value here instead. And so each time we want to rotate, we'll go through and we'll do that. So one rotation would do that one time. So for time p in times range like that. And then at the end of it all, we want to set self.image to be this new image and return self.image. So this is where it gets controversial, right? Is like, do we want to instead hold the we should just compute it once and hold each of those outcomes for our image orientations, right? So instead of having a tile hold a single image, we should have the tile hold all 8 images. A single image dot append. So it's like first image or orig and images just gets appended to this original image. So we get one original image and we do all that, and then we say self.get rotations, right? So that's what we really want from here, or create rotations. So we don't need a times, it's going to do all of it. And so in each of these rotations, it's going to look at this original self.orig image, which hopefully we should make this a instance variable. And so it'll be in the original rotation, then the whole thing, then it'll flip it, and then do the whole thing. So copy image, new image, it's in the place. So each time we do it, we don't have to make a new image every time. Oh, but we should, because we're going to save it to the thing. So we have to allocate new images each time. So we'll make a new image, which gets returned from copy image, and it should copy original image. Oh boy, every time I have self.image, it's going to be upset at me. So something to fix in a bit here. So all the work for a single image, new image, do whatever, do stuff to add if needed, get borders. All right. So we should have self.images, images that append, get rotations. I wanted to also take care of the borders problem. I want the borders of each of the 8 images to be kind of separately stored, so I don't have to retrieve them manually every time. So that's like, in my tile library I have this one number and this one tile that's going to have like tile dot kind of borders, all borders, set of borders, like self.images, self.borders, and that's going to have maybe sets of left, right, up, down borders. But the order, top, bottom, left, right. Good job. Yeah, there's a lot of this is just like keeping track of everything. So it's a list of that. Whoa, not what I was trying to do. Alright, a list of those tuples whose indices match this original image thing. And so we'll deal with the get borders call shortly here. The first thing I want to do is make sure I can generate all 8 rotations reliably. So I have, for each rotation, we have these 3 rotations, and I need to append them to self.images. New image. See, part of me wants to, what am I doing here? Image, rows, append. So I save that, but then I put it inside of here manually. I'm not sure I want to do that. What if instead I created an original image and then I told it to get rotations, and get rotations handled all of it. So let's try that method. So we append original image, we do some sort of self dot get borders on original image of some kind. Like, I haven't written the get borders function properly yet. That I think I wanted to take a single image and find its borders and return them and just be done. Just make it a little helper function. So we go through, we do each one, and we should do its mirror image. So flip now takes on a new role where it takes, it's always going to be axis equals x. And for every, it's going to take an image of some kind, and it's going to flip it and return it. And specifically, it's going to create a new image on a local new image, and take this input image, reverse all of the lists in order. So actually it's going to go right. So that's yeah, it's still flipping along the x-axis. And then, so it's reversed, and then it should get saved. Oh, reverse always returns a new image. So we might be okay. Reverse iterator values of the sequence. Let's check that. A equals 1, 2, 3. A there's a dot reverse, which reverses a, and then reversed a, which gives you a thing. You have to do that to get it to actually render. It's fine. I can live with that. List. So that's the reversed image. And we don't care about whether it's flipped or not anymore. So this parameter goes away. Well, that was a lot shorter than I expected. Maybe we don't need to have a reversed after all. So we can do self.images append, self.images append of list reversed new image. So we're gonna kind of flipped, rotated, I guess this is rotate, flipped, and then get borders for each of these. Oh, okay, in that case I do need to save this. And the borders are positionally relevant, so we need to do this properly. So flipped image is that. And so we will append the thing. Now, what is, okay, we don't care about that. That's no longer a thing. Get rotations. So I guess we can return self.images, right? But yeah, I'm not saving that to anything here. List as image row. So this is just creating the original image. And so once the original image is created, I use that. I append original images to the thing. Oh, I also need to, this is why part of me wishes we didn't. Yeah. So we need a flipped original image. And appended. So everything we do down there we have to do up here, which is why I might end up, yeah, I could put this all in a function and just pass in the relevant image. Because I'm going to get borders too. And a lot of this is class level stuff. The other way to do it would be, we're appending these new images and I can just do them all as a group later. So I could move this out and just iterate through them all later. For image in self.images, then it won't be like a thing and its reverse. Rotate, a thing and its reverse. Like we're going to have the reverse ones come after the flipped ones come after the rotations, which I think I like that actually. So let me just make sure I get these variables changed out and then get borders. So one more time through in self.images. So now we're going to get borders, self.borders. We already have it created, right? Yeah. So it's really just a matter of get borders on image, and we'll say self.borders, borders.append, get borders, self.getBorders, and maybe do that to make sure I call the right one. We get the image. Maybe we'll put the G there. So it gets the thing, it gets the thing. we create it this way, and we're saying no, do it this way instead. Yeah, they're lists. So these are all separate lists. Oh boy, this is where the numbers I think could come in handy. Left dot append. Right dot append. And we've got our thing. It's already a tuple. The tuple gets appended. Good. So, self.join, which is a list. Right now it's not a list of strings. We want it to be a list of strings though. So if we want it to be a list of strings, we need to join each element's thing as well. So a list of for string in a given image. Oh, original image, maybe. So that's a list. So that is going to be joined with nothing. Join s. So for each row, we're going to make a string. So we're going to have a bunch of rows, and then, yeah. The question is whether we want to put it as original image or something else. But I think for now, that is okay. Like we have the ID and things like that, but for now, I'm okay with this. Let's run some tests. Where do we call get borders? We get borders somewhere. Get borders. Show me, yes, get borders. Borders are appended. Return, gosh, what do we even return? All the images. All right, this class has been like reworked so many times. Self.image reversed. Okay, that's fine. We get the rotations and borders. You know, it's like parenthetically, borders are also retrieved. And so in the end, we want to show images and borders as kind of, I want to display those. And I might borrow our code from this repra. Define display and like a specific image, right? So if we want to display a specific image, wow, that did not copy at all. So if we want to do a certain image, we can pass it in and show it off like that. And so we might also do something where def display list. And so that's like image list. And so then for image in image list, self.display image. Display shouldn't return, it should print. And yeah, that'll print each one. So we can just let that run. Okay, so what are we actually doing in our main code? We call parse1. Parse1, let's go to our structure. Parse1 reads the things. It still doesn't make any tile classes, so let's make some tile classes, maybe? Well, right now, let's see what it runs. It gives us back these little string doodads, and that is all. Because in part 1, we call part 1, we only print the first tile that comes back. Let's only parse the small input, and with these tile strings that look like that, we have a number and a thing. There's so many layers to this, right? Like we have our tile strings, which are a list of ID and then image strings. And so we are going to go through each one and create a tile with the numbers and image rows. Okay, okay. Tile. So for tile and tile strings, create a tile of T, the first one, and T, the second one. Probably could have just done T star there, or star T. And then we need to have a list of tiles that we want to be able to access by lookup. What do we call that in our thing? Tile library. Still calling it tile library. And tile library, library at T at 0 is equal to that. And we're going to return, let's just return tile library at one of these small input values. Let's do 3079. Assume we get that far. It is still running. That's not good. Yeah, that's real bad. Wow. Where even are we in the code? I mean, they're all for loops, so they shouldn't go on forever. Shouldn't. That is not great. Okay. I feel like I'm probably missing something dumb. Print title num. The autocomplete's broken. That's strange. Oh, because I wrote title. Creating tile 2311. And it got stuck here. Images append the original image. For T in range 3, images append flipped list. Reversed image. That all seems fine. I'll wait a little longer, see if I click stop later if it stops somewhere else in the code. No, it still stops there. Okay. So something funky is going on here. Huh. Print self.display new image. I'm going to say, oh, actually, display new image will actually just display it. I will print self.tile num and rotation T. Tile object has no attribute tile num. Oh, it's called num, not tile num. Gosh. Autocomplete is not broken, folks. Tile has no attribute image. Alright, so we're on rotation 0, rotation 1, rotation 2, and break. Okay, so this reverse thing is still crushing me here. Why? Images out of pen, new image. Is it not able to reverse? Print, flipping, flipping one, just say flipping, self.display, I'm gonna remove that. Oh, it's just flipping really slowly. It's also not stopping. Flipping, display image. Flipping, display image. Flipping, display image. And the images are display, they're double lists instead of strings now, which could be part of the problem here. I might not be able to just say reverse. Ooh. Oh, I see the problem. It's because I'm appending to it. So I'm making the list longer and giving myself more work to do. Yep. Good job. Good job, team. Flipped list equals blank. Let's do flipped list dot append self dot images plus flip list. Done. One shot. All right. Flipping, flipping, flipping. Rotating, rotating, rotating. Getting borders. So that is no longer needed. This is no longer needed. Although I am curious to see the rotations. I just want to verify that these rotations look right. Now, what? Oh, get borders broke. What? Why didn't that break earlier? That's fine. We can. That's fixable. Yeah, it's not self.image anymore. It's like a pure helper function. All right. So at least we did finish. I want to see some of these rotations. These rotations look a little bit wacky, especially that one. It's like super long. I'm printing something else, aren't I? What am I printing? Or displaying, whatever it's called. Flipped, display, self, rotation 1. And then at the end, we return this tile lib. Yeah. And it'll show the original tile. Maybe we'll have the repro show the number for now. Return self.num as a string. Plus new line plus that. And that'll allow me to return this without too much confusion. There's that number. Okay, let's take a look at these rotations. So rotation 1, right? This is 0th rotation. Compared to the rotation after that, it looks unchanged. Eek. Well, here's 30790. If we rotated it once, that first row is going to be a bunch of dots. Then one of these things, every other 1, 2, 1. 1, 2, 1. Next row is the same, but it's 3 space 1 space. Next row is almost the same, except it's 3 space 1 space. All right, so one rotation worked. The other two did not. I am so glad we are checking this. So we're appending new images. Clearly my copy image did not do anything. And I'm seeing the problem now. Yes, indeed. So new image gets appended here. And we're still rotating the old image. Ooh. So what should we rotate instead? The last, I'm really nervous to be sort of playing with fire here if I do images at -1, like whatever the last thing was, just use that and just like hope it works. But like this will work even if it looks weird. So like here's our first rotation, then the next rotation should be 3 and then 1 with 2 blanks, which is what we see here. This, what is this, 1, 2, 3, the fourth column is like 2 and then a bunch, or 2, 5, 1. So column 4 or row 4, 1, 2, 3, 4 is 2, 5, 1. And then if we rotate again, we have like 1s and 2s. Yep, that's 1s and 2s. And then over here, this should become the last row. 1, 2, 1 spaces. 1, 2, 1 spaces. So that's nice. And rotation 1, rotation 2, and then here's the original, which if this is the original, this is upside down. Upside down. I guess it's like backwards and top to bottom flip. So like this should go 3 and then 1 in rotation position 1, 3 and then 1. Yep. Okay. Rotations are working. Alright. We should check borders. Borders. It's going to be a lot of stuff. Yeah. It's a list of a tuple of a list. So it's going to have 1, 2, 3, 4, and then break. Another 1, 2, 3, 4, and break. How should we display borders? So the first one will be top row of the original. Oh, and the original is, oh, we're not showing it. That's, well, rotation 1 is, you know, upside down and backwards, so we could use that. So this is going that way, the top row, right? It's like 1, 1, 5, 1, 1, 5. And then this is bottom, so that's backwards, and here it's 1, 3 with spaces around it. 1, 3. I think more interestingly it will be 1, 2, 3, 4. Wait. 1, 2, 3, 4. I want to make the borders strings. I think that is the right thing to do here. Let's just make a top level little helper function. I'm going to call it join string or like compact. Given a list, we're going to compact by doing nothing join on that list and returning it like that. It's just a syntactic sugar, really. We'll update it as we go or as we need to. So this is like compact. Before we do that, whoops. I want to capture the original version in case I decide to revert that. Compact, 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 right. All right, much easier to read. So we got 1, 2, 3, 4. That's it? Where's the other side? Oh boy. Borders that append self.aha. This creates a new list, so we have to save it back to itself. Man, this is memory inefficient, like crazy. And then we can just do, let's just show the length. Save ourselves the counting trouble. Good, so there's 8 of those. And rotation 2. And we can see there's 8 images. And I want to see all the images. But not displayed like that. Holy crap. Display the list. Oh, it's an image list. So those are all helper methods that take an image. If I want to see the whole thing, I can do a repra on the original. That's something. All right, I think that'll have to be close enough for now. We've been working on this for an hour. I think we finally got to a good place where, in terms of the way the tiles are represented, I'm pretty happy with that. Let's go back to reviewing our plan. It's easy to lose sight of this when we're down in the weeds. Images, we still need this images class. We're not storing the borders as numbers right now. I think I'll move to that if we need to. Grab a tile, pick an order. Okay, so now it's kind of down to the tile grabbing, selecting, matching. No good match for edge, or just pick another edge. Like there's always going to be edges to pick from. Like imagine now we get to the end, right? And it's like, is this edge good? Is this edge good? Like we're going to have to go through a ton of edges because there's only going to be one corner left that's going to match. But I'm happy with how the class works. Like we go and we kind of create the tiles. So we've created all of our tiles, and then we can for T and tile. So we'll go through, get all our tiles, and then we kind of basically start assembling image class, right? Like, and so the way I see that working, it'll be like, we'll initialize a new image, and then we need to pick a random value from the dictionary. I don't even know if dictionaries have like a pop. Like we might just pick one to start. Let's just do that for simplicity's sake. So we like say image tile live at actually we don't need to do that. We can do full image is this, and we can do full image add tile. We'll manually add a tile lib at what did we call it, 3079 for example, and then we'll just keep adding them, right? Like, well, sometimes you can't just like pick one to add. It's more of we have to take what we've got and then choose to add something to it. Okay, so then it's not so much an image add tile, and that's why I was wondering if we should have it be, so really this should be something more like this, and then I'll start the image off with, you know, in this case 3079 for instance. So add tile from the dictionary, and we'll just keep doing that, right? Like while full image, you know, not complete. It's good. Yeah, I don't know if that'll be a function or not. We'll add a tile, and you know, inside of add tile is going to be all of our logic around keeping track of our list of edges. So image class needs to have some sort of, well, we can uncomment it now. Self.edges. So these are exposed edges for docking. And we want to somehow capture the like kind of value, orientation, and border of the tile that we are kind of holding. So we need to know the number, we need to know the, you know, there's a number, there's a bunch of things here we need to track. We need to track the positions of tiles, their IDs, their kind of, so I've also been thinking about, like, do we want this to be a list of lists again, or do we want it to be more graph-like, where we like, because we don't know which way it's going to grow, and so like we start with one tile and it's like, let's try the left edge, so then like the left edge hooks in like that. So it might be something where should tiles have left, right, up, down attributes as hooks, or docking bays, and we walk the graph. And so it's like all of the left, right, up, downs that are not populated are exposed edges, right? So all exposed are up, down, LRUD attribute without values that are none are available. All exposed borders, the LRUD borders, I'll keep calling them dots, but they're borders, are available. And then when we add something, we like find the one that's there and put it in, and then it's there. It's got potential. We just need to, and then when we print the image, we want to be able to print it somehow, like we need a handle, keep a handle on the upper leftmost tile. So then we always kind of, once we add something on, we do a check and we say, here's our current uppermost that we think it is. We try to go up as far as we can. We try to go left as far as we can. The problem is that we could have this patchwork, right? Like you could end up in a perfect scenario assembling an image that you accidentally picked the correct upper left, and the thing that docks into it is exactly next to it, and you just end up building a frame of the whole image, and then you just finish because you're like, I got all four corners, or at least I think I got all four corners. No, you have to finish the image. And so that's attractive to me. My concern is that there are ways to assemble this where it's like, oh, we can put this here, and then later it's like, no, this isn't good. Let's try a different one. Let's put something else here. That's where it will really get dicey if that's the case. I'm hoping it's not, but it might be. And that's where converting the borders to numbers would be useful for visualizing what's going on. If we converted the borders into binary and then into decimal numbers, we'd be able to see what the overlaps are on all of the possible kind of combinations. And I guess let's wrap this video up with that. I'll do a little analysis of all of the tilelib borders. So for k value in tilelib, value.borders, right, that's just, yeah, borders, is a list of, did we already convert the, I think we compacted our borders, so to speak. So where's the get borders function, right? So we made the borders into strings. And so this means we need the borders, and then we can say, and then we have, this is a list of borders, and let's just get the first border and then we'll do its reverse. So borders at 0, and borders at 4 flipped. This is original. And we're going to take those borders, we're going to do a dot replace. Let's do, take this as an example. A dot replace dot with 0. And then A dot replace, I think I should have saved it back to A for the real thing, 1. Yeah. So yeah, we saw this. Man, there's a lot of overlap here. Orig, flipped, for image in orig. Well, let's just keep it simple here. Orig, orig dot replace, no, replace dot replace, and we're going to do that for flipped. So now we have numbers, and then we're going to convert A equals A dot replace. So now A is this string. So orig flipped, and then sorry, I'm trying to get this to come back. Okay, A is that. Let's do B equals this. We're going to do int of this whole thing, and B is a number. Great. So still the same methodology as when we converted other stuff to binary with the seats in the airport waiting room. So now that we have the borders, oh, we don't have all the borders yet. One more thing. Orig is orig image, let's just call it. And flipped is flipped image. So that's a tuple of 4 borders. And so the 4 borders now for orig, in, orig, image, like of the borders, that's what we want. And similarly here, for flipped, in, flipped, image, that's what we want. And so these are the numbers that will go into our borders analysis pile. Let's have the I'm trying to decide whether to put all 8 together, group them by 4s, or put all of the possible numbers into one big smorgasbord. Because it's like you can only have it be flipped or not flipped, right? You can have it be rotated whatever way, but like once you flip it, all the numbers have to change. And so they're kind of like either or. It can't be both. Yeah. So it's sort of like, it's like that or situation I saw before with the other one. All right. At a high level analysis, let's just group them together. I know it's a bit sloppy. It's not my favorite. All border equals list. So this should be a number, this orig. And so all borders dot append orig, and all borders append dot flipped. So these are all of our borders, and so we should be able to do a little all borders dot unique. Well, yes. Import from collections, import counter. So we're going to use counter on all borders. That will give us a nice, whoops, wow, I went into the init.py of counter. So we take all borders, we save it as, say, border count, and let's just, let's print border count for now. I want to see what that looks like. What did I do wrong? Oh, yeah, let's just not worry about that for now. All right, in object is not iterable. Tile lib is not an. What? Tile lib. Oh, items. The keys are in are integers. Great. All right, here's our counter. Oh. Why are there so few? I also then want to print out the size of this. What the heck? Okay, there's 9 things, and 1, 2, 3, 4, 5, 6, 7, 8. That's like one. Here, all borders needs to come out. And get the borders, get the original images. Now we're talking. So we got some counts. There's definitely a fair degree of overlap, but some unique edges. It's a mix. And if we remove the flipped ones, I can just not append them here, then we end up in this situation. There's still some duplicates. Okay. So that has interesting implications in my mind about the search space. Like there are situations then where multiple borders have possible matches. And a border that is the same value shared across 3 different tiles is interesting because, well, firstly, I don't know if it's from the same tiles or not. The most interesting tiles are these final tiles here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 borders that have no unique matches. And in a 3x3 grid, which is what we're dealing with, there are 12 externally facing edges. Now keep in mind that we are combining all of the borders from like in both orientations here. So this is not 9 tiles times 4 edges. This is 9 tiles times 8 edges, in theory. Print border count, print this. Well, what about this? Length of all borders. Yeah, 72. And so we could check kind of, how many borders are on the non-flip sides that are unique. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, like a lot. But when we do both, it gets more interesting. And in particular, I am wondering now, I want the count of all of the values that are 1. Counter of border count. Right, I'm going to get the count of these count values. Call this the meta count. No. Border unique. And really I can just do border unique at 1, but I'll take a look at the whole distribution. Why not? So it's like there are 17 things with 2, 13 things with 1, 4 with 4, and 3 with 3. And so now, what does it look like for my input if I don't screw up the whole thing? Out of range? For S in image? How the 1303 rotation 2. It's the last thing, and somehow I blew it. I'm guessing it's this. Yeah. So this is a 12 by 12 thing. So before I look at the numbers, it's a 12 by 12 grid, right? We had 144 tiles. So that means there's 12 on this side, 12 on this side. So it's 4 times, so it's 36 outer edges. And I'm seeing 184 singletons. Cool. And a ton of these other higher order matches. All right. So no shortcuts here. I thought maybe we could get away with like only looking at things without any outer matches. But at the same time, it would be less useful to look at things with only one match, and potentially more useful to look at things with exactly two matches, because we know those have to be connected. Maybe we should have done this earlier. There are edge pairs that have a single match. I guess it's really just edges. Single other match. They must be together. So in this example, there are 216 edges that match perfectly with each other. They don't have to be together. They have to be together if they haven't been used / are not on the same tile as itself, things like that, as each other, right? And so when you eliminate those, I wonder what we're left with, right? Like we have 216 possible edges. That's 108 tiles with unique matches, or edges, 108 edges with edge pairs with unique matches. And so it's like if we just grouped all of those together and had these like loose islands, how would that look? The difficulties of like munging together two irregularly shaped partial maps aside, it would be interesting. So like if we were able to isolate, can we isolate the list of, and by isolate really what we're trying to do is narrow down the list of tiles with unique pairs of edges to reduce the search space? That's essentially what I'm asking here, because I bet a lot of, there's 140 with three-way matches, 29 with four-way matches, so like there's no shortage of tiles with high matches, right? There's 144 tiles, and we have over 144 with three or more. But they're pairs, or triplets in this case. So it's like when there are 29 edges with four buddies, it's really saying there are 29. Well, it's saying that there are 29 things, so they're like these, right? So like 326 has four edges. Oh, we're already accounting for the fact that there are four of them. So with 216, there really are 216, edge codes, border values that are doubled. Oof. Okay, so there's a lot. Good stuff. We're making progress. This is a substantial coding challenge. It's possible that we will just kind of keep chipping away at this over the course of the next few days, and kind of I'll probably like do a stream later on the day 21 stuff and like try to solve that. And hopefully that won't also bleed over, like otherwise this is going to be a real long slog over the next kind of couple days. But yeah, hopefully this was at least somewhat interesting. We're really getting into the nitty gritty around like software design here, and part of me is still just like, am I doing it the wrong way? I hope not. I'll keep kind of thinking on it, but I'll be sure to capture our actual coding work on the stream. And yeah, with that, we'll try again later today, and we'll do day 21 as well. Can't forget day 21. And yeah, thanks for watching.